Bienvenue dans cette
Hello
nouvelle
and
vidéo.
welcome to this new video. Today we're going to take a look at the jar test for coagulants, also called jar test flocculation. I remind you that we are in step 4 of the water supply cycle corresponding to the pre-treatment. If the turbidity of the water is high, disinfection of the water by chlorination will be ineffective. You remember that the recommended turbidity for effective chlorination is 5 NTU, as we saw in the video on measuring turbidity. Be aware that the maximum value of 20 NTU is tolerated during the critical phase of an emergency. Beyond that, turbidity should be reduced. If the particles responsible for the turbidity are relatively large and heavy, they will naturally settle in the still water, but this process can take a long time on large volumes, which is not possible, especially in emergencies. This is why at MSF we use a chemical or biological substance called coagulant, which allows you to accelerate the natural sedimentation. At MSF we mainly use 3 products. Aluminium sulfate, which is the best known and most easily available coagulant in the world. It's available in this form, and here is its code in the MSF catalogue. Ferric chloride, which is presented in this form, and here is its code in the MSF catalogue. Pax XL10 polymer, based on aluminium in liquid form. You will find the advantages and limitations of each product in the technical sheet 2.14 of Public Health Engineering. But let's get back to the subject of this video, the flocculation jar test. The jar test is used to determine the amount of coagulant solution required to treat a certain volume of turbid water. In this video we will focus on the jar test using the aluminium-based Pax XL10 polymer that can be used in its pure form. To perform the jar test, you will need the following materials. Pax XL10 coagulant, which can be ordered in a set of 2 times 2.5 litre jerry cans at the price of €39 at MSF Logistic. 1 mixing stick, 1 pair of safety glasses, 1 pair of gloves, graduated buckets of 10 litres, 1 graduated syringe of 10 millilitres. The first step of the jar test consists of filling 5 buckets of an identical volume, here 10 litres, with the raw water to be treated, and to identify them on a register or on paperboard. Caution: for flocculation jar tests, we recommend that you take the sample at the motor pump outlet in order to obtain the most accurate turbidity. Do not forget to wear gloves and eye protection. To make the second step easier, I suggest you pour a small amount of polymer into the cap. This step consists of taking progressive doses of polymer and adding them in each of the buckets. Here we use 0.5 millilitres in bucket number 1, 1 milliliter in bucket number 2, 3 millilitres in bucket number 3, 5 millilitres in bucket number 4, and 7 millilitres in bucket number 5. Each time you inject a dose into a bucket, you will need to stir the water with the syringe or a stick, being careful not to spill the contents. It is advisable to make a circular movement in order to create a swirl and to ensure a homogeneous mixture of the product. Once you have added a dose to each bucket and the vortexes are moving, you should observe the formation of flocks in each of the containers. This process only takes a few seconds with the polymer. Then wait 30 minutes after the mixing process is complete for the flocks to settle. The next step is to visually compare the results in the different buckets. The bucket with the best result and the lowest dose will be selected. If you are unsure of which bucket to use, the ideal dose is probably somewhere in between. Now check that the turbidity is above 5 NTU. To do so, carefully pour the supernatant, i.e. the clear water, into the turbidity tube. Be careful not to stir up the flocks at the bottom of the bucket. This could distort the result. Be sure to distinguish the circle at the bottom of the turbidity tube. The next step is to extrapolate the jar tests for the volume of water to be treated. We will use the standard 30,000 litre tank as an example. Here we have determined that bucket number 2 gave the best results. Knowing that we've added 1 milliliter of polymer to 10 litres of water, we just have to make a cross product like this. Let's consider X as the measurement we're looking for. 1 milliliter is enough for 10 litres. How many milliliters for 30,000 litres? 10 times X equals 1 times 30,000. X equals 30,000 divided by 10. X equals 3,000 milliliters, which equals 3 litres. It will therefore be necessary to add 3 litres of polymer to treat 30 cubic meters of raw water. Remember to record the results in a logbook with the location, date, time, and your name. I remind you that you will find all the steps of this procedure on the technical sheet 2.15. In case of doubt, do not hesitate to ask your technical reference in the field. Thank you for your attention. See you soon for new videos.